Now let's take a look at absolute value functions that have a quadratic in them. In other words, you're looking at something that has an x squared. You know what this looks like. Recall, this is going to give you some kind of great little parabola. But let's be a little bit more accurate than that. We can solve this several different ways. We can find out what these intersects are by doing two different things. We can either realize that this is, of course, a difference of squares. So that means, okay, this becomes x minus 2 and x plus 2, and we can solve each one by letting it equal to 0. So x is going to equal to plus or minus 2. Those are your critical points now. Or you can turn around and say, okay, we can go x squared minus 4, which of course is going to equal to 0, and then solve it by adding 4 here, adding 4 here, right? Giving you x squared equals to positive 4, and then square rooting it and realizing that the square root principle gives us plus or minus 2. Perfect. Either way, it doesn't matter. I want you to see what this guy looked like before we made it an absolute value. So with that in mind, let's use these nice little critical points here. Okay, so recall what it was. It was x squared minus 4, y equals 2. Perfect. So plus or minus 2 is right here. There's minus 2. There's plus 2. And remember, this, if you let y, or I should say x equals to 0 to find the y-intercept, okay, you'll find out that that cancels out, leaving you y equals to minus 4. So there's your vertex at 1, 2, 3, minus 4. So your parabola looks an awful lot like this. It comes down here, goes all the way down to here, and then back up like that. Perfect. Awesome. So there's your parabola. Now, let's think about something for a second here. If you look at the original question, it was y equals to the absolute value of x squared minus 4. Think of what absolute value means. Absolute value means everything has to be above the x-axis. It has to be positive in this case. All right, so wait a second. We're okay here. That's fine. That's above the x-axis. We're okay here. That's above the x-axis. But look at this guy. Wait a second. That's not above the x-axis. So remember that this was minus 4. And if we absolute value this, that gives us plus 4. So 1, 2, 3, 4. The vertex is now here. And every one of these points all the way here become these points all the way here. You see it? Now, look, that means these are here. So you're going to get a graph that looks an awful lot like this. There's the absolute value graph. The absolute value graph is all here and goes here and up. That's what it looks like. Does it satisfy the condition that everything's above the x-axis in this case? Yes, it does. Proof positive would be going over to your calculator. And if you go out and graph this thing, so again, we have to find the absolute value, which you hit math, you mouse over, there's the absolute value, bada bing. And again, depending on what kind of calculator you have, it could say ABS, or it could actually have the symbols for absolute value. Put in x squared minus 4, close the bracket. Watch this. This is so cool. There's our beautiful graph. Exactly what I just gave you. Okay, so how do you go about doing this? Real simple. If you think about this, put your critical points down by factoring. So you're going to have to factor either PSA or difference of squares or whatever. Find your bottom vertex. So the critical points are here and here. Find your bottom vertex, do the absolute value, pop it up here, and you get this beautiful graph now that goes all through here, boom, 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 like that. Everything's fine. But now look what you have to do. Don't forget, you have to piecewise this function. You have to tell me the answer in piecewise notation. So I have my piecewise right here. I'll move it up a little bit. There we go. Perfect. Let's figure out the piecewise for this. Remember, this was at minus 2 and this was at positive 2. Okay, here we go. So where is this? This, our original function, our original parabola was here. Don't forget, that's the one in red. Okay, so originally, you know that this was above and this was above, so everything's normal. Here's a positive value of x squared minus 4. So the positive part of the parabola was here and here originally at minus 2 and positive 2. So at x is less than or equal to minus 2, that's this section starting here and going here, it was positive. At this point, starting here and going here. So, okay, we have to put down x has to be greater than and equal to positive 2 because we're starting to look at this section. Now, the question was, what happened to this section? This is the section that was flipped. All right, so let's flip the sign. Okay, and where was it flipped? Between here and here. So it's flipped between the x equals to minus 2 and the x equals to positive 2. It was flipped. So the flipped section starts on the minus 2, is bigger than the minus 2, so it goes this direction here. And it's less than a positive 2, which is in here. So we're talking about this section right in here. All right? That's how you do these ones.